So in the last video, we wrapped up talking about types of reasoning in some sense, and I promised that there was a different approach to trying to determine whether a particular argument is valid or invalid that doesn't require attacking it via Venn diagrams. There's actually a fair number of arguments that don't follow the types of formats that work really well there. Before we get there, I did mention we kind of gotta put some tools in the toolbox, so to speak, in order to take care of that. So that's where we get started in section 1.2 of the course, talking about what I'd like to call symbolic logic. So in some sense, this may end up feeling like we're taking sentences and somehow turning them into algebra expressions. So bear with me. Like I said, we'll walk ourselves through this. So the first order of business is I need to establish sort of some base ground rules for what we're talking about. We're not considering all types of sentences. We're being very specific about them. Particular sentences called statements. A statement is a sentence that is either true or false. So some examples are given in the PowerPoint slides. As a heads up, I have posted PowerPoint slides in Moodle. I'm taking it for granted that you've got those handy while you look at this. So, for instance, the sentence, "Your professor owns a cat and a dog," is a true statement. I'm not going to try to wrangle them in here so you can see them right now, but I promise I do in fact own a cat and a dog. If you showed up in my house, you'd see them running around. Another statement listed there says, "Your professor has seen the movie The Lion King." That is in fact a false statement. I really have never seen The Lion King. Go ahead, make your surprised faces. I'm used to it. It's a long story. It's not terribly exciting, but I have not seen The Lion King, either one of them. So there you go. The next slide lists a few sentences and asks us basically to parse whether given sentences actually are statements or not, following that true-false connection. One of them is a question. Generally, folks say, well, yeah, a question can't really be true or false. I guess your answer to it could be, but the questions are based on a video game called Metroid that came out when I was a kid in the mid to late 80s, so I like video games. Sorry if Metroid is not your thing. But there's a third sentence in that list. I gave you four. Sentence number 3 says that Metroid is the best NES game ever. You probably recall when we talked about set definitions back in in the first night of the class. The word best is kind of subjective by nature. I'd have to get more concrete about what I mean best in terms of like a rating on Metacritic or best in terms of best selling. I'm pretty sure Metroid isn't the best by either of those standards, but as written, with best written as it is, yeah, that's not really a statement. Whether it's true or false cannot be determined. The top statement and then the bottom sentence, both of those guys do check out as statements. The top one says something about the main character of Metroid being male. That is in fact a false statement. Samus Aran, the protagonist of many games with Metroid in their name at this point. It was kind of a big surprise back then, and it kind of shocked people. And you had to finish the game really fast to find out that Samus was a woman, because she's wearing like Iron Man power armor. And if you don't beat the game fast enough, she just stands there in the armor. If you do it fast enough, she takes off the helmet. You see she's a woman. Big surprise for boys like me playing in Nintendo games back in the late 80s. Anyway, the bottom sentence is also a statement. Unfortunately, Gunpei Yokoi, the producer behind the original Metroid, he died a while back. So that is a true statement. I wish it weren't. But so the symbolic part of this, you're like, okay, we've talked about statements. Where do the symbols come in? We're generally going to represent statements symbolically, like what you might call a simple statement, something that you can check off real quick, true, false. Like Metroid's main character is male. That's a statement. I'd represent that with a single letter, kind of like a variable in an algebra class. I usually start from like P and tick my way down, P, Q, R, that kind of thing. If you want to use letters that are a little more evocative, that's fine as well, but that's kind of my standard operating procedure when it comes to this. So, letters like statement P, Metroid's main character is male. So, that's kind of the setup. Now, we're not generally going to be interested in what we call simple statements by themselves. We want to put them together, sort of like how we don't just use numbers, we add them and multiply them together with math operations. We're going to have logical operations that sort of do the same thing. So we're going to form what we call compound statements. We take simple statements and we hook them up with operations. We call those logical operations connectives because they're kind of linking things up. So hopefully that stands to reason. There's a list of our basic connectives posted in Moodle. Take a look at it. Feel free to go ahead and grab that. Press pause if you need to. I'm a big boy. I can handle it. So, because most of the statements we're interested in are not that direct. For what it's worth, one of the very first example I gave you about owning a cat and a dog, that was actually a compound statement. I was saying two things at once. I own a cat and I own a dog. So you got to be careful with things like that. Sometimes a statement may look simple on the surface, but it turns out there's actually a compound floating around in there. And we're going to talk about the various kinds of words that might end up cluing you in that something like that happens. We'll make our way through the list as we go. So I've got listed in the PowerPoint slides a handful of simple statements that we're going to work with. Simple. I didn't mean that. Sorry. So statement P says a student misses class. Student Q says a student studies. Statement R says a student fails. So we're going to be working with those guys and sort of taking sentences, turning them into symbols, vice versa. So the first operation I want to take a look at, the first of those connect is what we call the negation of a statement. So the negation of a statement, so I'll write, like that is a little twiddle. I usually call it twiddle if you want to use tilde. You can also just read this as not P. The most common way we would negate a statement, it's like a logical opposite. So it would make sense introducing the word not into a sentence, would work out. So a student does not miss class. So yeah, that's kind of the flag there. If you see not in a sentence, you probably want to translate that using a negation in some way, shape, or form. So we could work through similar exercises. What does it mean if you say, a student does not study? That would be the negation of Q. So negations are reasonably straightforward. They kind of have an analog to like set complements. If you think back, there's actually a fair number of parallels between the set operations that we saw in Chapter 2 and then these logical connectives. We'll talk more about those as we get into dealing with truth and falsehood more carefully. But so the next operation I want to take a look at does in fact require two simple statements at once. It's the conjunction of two statements. So it's represented with this thing that looks, like an upside down V, or maybe like a caret if your calculator has an exponent key that looks like that. So it's a conjunction. The most common way we would refer to that is using the word and, P and Q. So we have a student misses class and a student studies. So again, and is the flag there. You'll also hear the word but used in the same context to accomplish the same thing. That's to be honest, they'd probably expect the word but to appear here instead of and, just because this sounds like a bad thing, this sounds like a good thing, so different connotations would often end up introducing the word but. Logically, they're both still classified as conjunctions, though, as far as the logical structure goes. So that's that. So up next, I haven't talked about statement R yet. I hate bringing him up, but anyway. So next up, we have this thing that really does look like a letter V. So for what it's worth, if you're wanting to use symbols, you might want to avoid V because it does kind of look like this guy. This is what we call the disjunction of a pair of simple statements. So Q or R is how I would read that. And I know if you're like me, you may think, well, or is a conjunction. I listen to Schoolhouse Rock. I know what they are. I get that. From a logical standpoint, though, or is something different. We'll talk about what that ends up meaning again when we get to truth and falsehood more carefully. But for now, if you see that V symbol, that's a disjunction. You most likely want to put that as or in a sentence. So we have here a student studies or a student fails. And I will go ahead and warn you guys right now. I tend to be a little glib with the individual, verb tenses, things like that. You probably say a student studies or fails. You might say a student studies or the student fails. For the purposes of Math 107, that's fine. I don't want anybody to get hung up that they don't have the exact, wording I need, so long as the logical structure is holding up. So we've dealt with the basics. I want to talk about one more operation here. I don't actually need to erase because I've got a little room at the bottom. So let's take a look at. Let's see. We'll do it this way. Let's do. Yeah, so we've got that arrow there. That indicates what we call a conditional statement. So I need to be careful because I've used arrows for this other stuff before, right? So I'm not going to write that there. The magic word for me that ends up, making something jump out as a conditional is the word if, possibly the biggest two-letter word in the entire English language. So if the student, this is class. Generally speaking, it should say if, and then we'll have a then that goes along with it. Sometimes that gets left out in English. I'm sorry, I can't, it's my language, but I didn't make it. So then the student fails. So that's kind of the baseline that we're looking at here. So if the student misses class, then the student fails. Like I said, the if is the really important part. Like I said, then usually is kind of assumed to go with it, even when it doesn't get listed. So negation, conjunction, disjunction, conditional. There's actually one more connected, but we won't get to it for a bit. One last thing I want to mention before I hit the pause button on this video and start a new one is in this format, I generally write my conditionals like this, but because English is goofy sometimes, that's not the way they always get structured. Every now and again, you'll see something, where a person writes a sentence along the lines of, a student fails if they miss class. That's really the same thing as this guy right here, because the student's failing depends on the fact that they're, missing class. So, my general rule of thumb that I tell students when it comes to this is follow the if. Leave if with whatever is on this side of the conditional arrow. Then is the guy on the other side. So if you have to move them around, follow that. That should help you out. I want to play around with a couple more examples of this in our next video, and then we'll do some other stuff. So stay tuned.